things you should already know. You should know already how to add and subtract integers, as well as to identify like terms. Some key terms to note. Like terms. Like terms have the same variables raised to the same power. Powers, otherwise called index. This is a small number to the top of a variable. It tells us how many times that variable is being multiplied by itself. For example, a squared is exactly equal to a times a. We're multiplying a 2 times, so to speak. Now remember, multiplication is commutative. This means it doesn't matter the order in which we multiply variables. The answer will always be the same. For example, a times b is exactly the same as b times a, which is exactly the same as ab, which is exactly the same as ba. So ab and ba are like terms. Now we've been talking about like terms. And remember, like terms have the same variable raised to the same power. So for example, if we're dealing with a, we have a. Or we look for all the a's. If we're dealing with b's, we look for all the b's. If we have y's, we look for all the y's. If we have y squared, though, we look for all the y squared. Let me give you an example. We have 2a plus 3a. If you notice, we have a raised to the first power right there, and we'll also have a raised to the first power right here. So what I can simply do is this: a, write it back, keep my variable, and the coefficients, I'm going to put them together. So 2 plus 3 will give us 5, and we'll have 5 a's. There you go. We simplify that just like that. So let's say I have 2 apples, and my friend came over and gave me 3 more apples. How many apples do you think I will have? If you said 5 apples, you're perfectly correct. Notice I keep back the variable. Let's do another example. Here we have 5a squared minus 7a squared. Let's check if we have like terms. Here I have a, and it's raised to the second power. That's what that little 2 up there means. And here we have a again raised to the second power. Same variable, a, same power, 2. So these are definitely like terms. So what I can do is keep back the term, the variable, and the power, and I'm putting the coefficients together. 5 take away 7, and I'm putting them in brackets. Now, this can be a little bit tricky. Let's say that you owe somebody $7, but you only paid them up $5. Do you still owe the person, or did you overpay the person? Well, I hope you said you owe the person same way. So if you owe the person same way, the sign we use to represent that we owe somebody is negative. Then now we need to determine how many persons or how much do we owe. Well, if you paid up 5 and you have 7 to go, 5, 6, 7, that's 2. So you still owe them 2. And what are we dealing with? A squared. So I have to put on my variable raised to the same power. As easy as that. Let's look at another example. Here we have 6a squared b plus 2a squared b minus 4a squared c minus a squared c. Let's go through. Alright, I see a here raised to the second power with a b. Good. I see a here raised to the second power with a b. Great. I see here a here raised to the second power, but this time it has a c. Not a like term, so I can't put my blue crayon under that one. It's different. There we go. What about this one? A squared c. Nice. These are like terms. Now I can put the like terms together by grouping them. When you look at it, all the a squared b's are together and all the a squared c's are together. So they're already grouped. Now what I need to do is to simplify it. How we can go about doing that? Keep back my variable, raise to the same power. So I have a squared b, and then I will put the coefficients together in brackets in front of the variable or the term. So I'm going to have 6 plus 2. So let me show you now. This 6 comes from here, and this plus 2 comes from here. Then I have the next side to look at. They are the same terms, like terms, so I keep back my term. A squared c. What will I do next? I will put my coefficients together. And remember, I'm keeping the signs. So I'm going to have minus 4 minus 1. Now remember, when you see a variable on its own, it's just 1 is seeing by itself. So this is 1a squared c over this side. So let's put them together. Notice that this minus 4 comes from here, and this minus 1 comes from here. So I have 6, and I'm adding 2 to it, means I'm going to get 8. 8 what? 8a squared b. Now this is the trick. This is where everybody get catch now. Imagine you owe somebody $4. Four finger, owe them $4. And I went ahead and owe them $1 more. So if I owe them 4, 1, 2, 3, 4, and I go owe them 1 more, poof, how much do I owe them in all now? 1, 2, 3, 4, 5. So I would owe them 5 right here. And what am I dealing with? A squared c. And that's it. As simple as that. I cannot simplify it any further because a squared b is completely different from a squared c. And that's it. Let's look at this one. Kind of long and complicated and overdrawn out, but same procedure. Just look for the like terms. Same variable, same power. Let's go. We have minus 5x squared y. So I'm looking for all the x squared y's. Let's look at this one. xy squared. The square is in the wrong place. Not a like term. Let's go through now. 2x squared y. X squared y. X squared y. Wow. These are like terms. Same variable, same powers. Okay, let's look through again and see if we see any more. Alright, xy squared. Okay. Let's look again. xy squared. Yes, we found the next one. Very good. So, minus 7xy squared is a like term to positive 3xy squared. And minus 5x squared y is the same or like term with positive 2x squared y. Now, let's put them together. I'm putting all my x squared y's together. So I'm going to have minus 5x squared y, and I'm adding 2x squared y. Then I'm going to have on the other side 3x squared xy squared plus 3xy squared, and notice that I'm carrying the signs that are in front of them. I'm carrying all the signs that are in front of them, right? So the last one now, it's minus 7xy squared. So see, minus 5 plus 2 plus 3 plus 3 minus 7 minus 7. Let me just put them back so you can see. There you go. There we go. The like terms are together. Here we go. Here we go. Great. Now we can simplify them. So I'm going to write up my x squared y, and I'm going to deal with these coefficients. I'm putting them in brackets. Minus 5 plus 2. Then with this side now, my variables are x, y squared, and I'm dealing with my coefficients in brackets. Positive 3 minus 7. There you go. Now, think about it. You owe somebody $5 and you pay them $2. That means you're going to still owe them because you pay them less than what you owe them. So you're going to owe them. The fact that you owe them, you're going to get a negative. But how much? Let's work it out. You owe somebody 5 fingers, so to speak. Right? This is what I owe them. And I only paid up 2. 1, 2. So what is left is what I still owe them. So I still owe 3. So I'm going to owe 3. And I'm keeping back my variable, x squared y. On this side, let's look at it. There's 3 and I owe the 7. Okay, we owe 7. Alright, so this is 7 and I owe them 7. So these 7 fingers represent how much I owe. But I only paid up 3. So I paid 1, 2, 3. So I'm left back to pay them 1, 2, 3, 4. So I still owe 4. And the fact that I owe means I'm going to use a negative sign. So I owe 4xy squared. And we're finished. We just made it simple.